Hello, my name is Joshua Lasoji, and this is video assignment 2 for Organic Chemistry 1, going over reaction coordinate systems. So my two reactions that were given are here on the top, and they're both basically ionizations of the given compound utilizing different solvents. The solvent in the first reaction is ethanol, and the solvent in the second reaction is DMSO. And drawing these two solvents out, you'll notice that there's a higher dipole moment in DMSO than there is in ethanol, and that's due to the fact of the electronegativity difference between sulfur and oxygen compared to oxygen and carbon and oxygen and hydrogen. And so that being the case, I basically said that because DMSO is more of a polar solvent, it's easier for it to ionize the compound. And thus I would assume that the reaction with DMSO would go faster. And so in drawing my reaction coordinate, I wrote that the faster reaction, which is the DMSO, has a lower activation energy because the kinetic product, which is the faster product, has a lower activation energy. And then I wrote that ethanol has a higher activation energy in this case, which would make sense because we expect it to go slower than DMSO in ionizing the compound because of its less polar abilities as a solvent. Now, according to Hammond's postulate, the transition state would most resemble the products because they're lower in energy thermodynamically than the reactants. And lastly, the bromine would just leave as a leaving group. Here's kind of the mechanism for that. It would just kind of take the two electrons from the bond and leave, and it would be a strong leaving group because it's a halogen. And yeah, that's it.